It's difficult to keep tabs on tens of thousands of items that are in a constant state of flux, really.
Manholes, valves, fire hydrants, pipelines, pump stations.
Zones for our police.
Locations of wildlife corridors. Photo points for some of our monitoring programs. And
all of our infrastructure, our storm drains, water, sewer.
Populations of sensitive plants, sensitive animals.
Sensitive areas of habitat.
We have our traffic volume database.
Land value, as well as property owner interest.
Mapping done of our trail system.
Identify certain areas that we could outline.
We have our parking inventory.
Land uses, agricultural preserves, those kinds of things.
The exact addresses and streets with very, very high degree of detail.
GIS still is the master keeper of the addressing system in our city.
I've been real happy with the adaptability, if you will, and the many things that the GIS system is capable of doing for us. All we have to do is ask.
A lot of that stuff's already mapped in GIS. It gives us the ability to lay it out in a map and also assign information fields to it and other documents.
We like to use mapping as much as possible because it's something that facilitates our ability to communicate what our policies are and what the rules are in the city of San Luis Obispo.
Others that come in handy are the utility information, the sewer and water books that are now in GIS. Very easy to find with a lot of good information.
Aerials are probably one of the key things that we use in a lot of design in the traffic division. Any type of signal design, roadway design. The first thing that we do is we go to the aerial and we look at what are the geometrics of the roadway.
The map books are created from the graphic information that's in the GIS system and referenced geographically in terms of analyzing how much land area was devoted to specific uses, how much land area was in various types of open space reserves. In this case, mapping was its primary function, and it performed that service very well.
Specifically on the sewer books, the elevation data for each manhole comes in handy. It makes the preliminary design go very quickly on a sewer project.
To strategically just look at things, we'll do aerial photos or we'll do regular map layouts so that we know where to position people and our captains use it through planning a lot.
We can do the on-the-ground stuff. The GIS department is able to produce a map to show to the public, the agencies, exactly what's being done, just to make sure that the city is compliant with everything.
There are a lot of questions regarding what's in the ground, where it is, what is it, what size is it, what material it is, how old is it. There's a lot of information that, from a graphic standpoint, whether it's on the computer or in a map book, you can pull off of that system.
We've managed to utilize your services in mapping the whereabouts of all of our water meter locations relative to parks. Our whole urban forestry inventory is, I just heard a squirrel over there. By using a handy-dandy GPS locator, theoretically, whenever we pop one of these bad boys, we'll just simply make a little mark in the ground, hook up to the satellite, we'll have that reference, and over time we'll reduce this pesky problem. Eradicating the pests themselves is good, but getting rid of their burrowing system is even more powerful.
Another project, the South Hills Natural Reserve Conservation Plan that the city is currently putting together, we went out there with the GIS department and GPS'd sensitive plant locations to make sure that any management actions that are undertaken by the city on that property, we're not going to be further impacting sensitive plant species.
We worked with the GIS folks to document the locations of about 6 or 8 species of rare plants that are found in those hills and in some other similar habitats around the city. And so we had a pretty good mapping of where to anticipate these plants, and that gives us an idea. If we weren't able to cover everything, you get an idea of the sorts of places where you might want to look to try to find those plants. Maybe it's on a north-facing slope that's kind of shady in the afternoon, or that sort of thing. Maybe it's on the south side, it's very hot and dry. So that has helped us not only to identify the individuals, but or the populations, but to kind of characterize where they're found, which is very helpful.
Also identifying where exotic species are on the property so that we can track the progress or the regression of those over time to make sure that we're keeping everything under control.
We use GIS extensively in developing the housing element and analyzing how much land area was available for additional housing and mapping those areas, and it was excellent for that. Many of us have the rudiments down on mapping, using GIS for mapping, but doing the spatial analysis is really the most powerful aspect of GIS in terms of planning.
You know, we want to know in a neighborhood whether or not the commercial areas are within walking distance to the majority of residents. And we want to try to make sure in the city of San Luis Obispo that people have access to services within a half-mile radius of their residence. And so we use GIS and use the buffer and use tool, and we use circle diagrams to illustrate that. Yeah, the city of San Luis Obispo is somewhat unique because our grid is not on a true north-south axis, but is skewed probably at least 15 to 20 degrees. With that skew, building faces on our downtown streets do have access to sunlight during different parts of the day. So those building faces that are oriented towards the morning sun, and then how the sunlight and its direction moves throughout the day and hits the other building faces closer towards sunset.
On our sex registrants, they are in our system and they're cataloged where we can run a query for all sex registrants, click on our icon for the map, and it would appear. If we want to know relationships to schools or relationships to certain areas, we can just query those areas and throw them on the map.
Our GIS division graciously created a tin for us, and what we did is we divided that up into small watersheds for the drainage inlets that we surveyed. It gives us a way to quantify the amount of water that comes into our system, and using the watershed modeling, we were able to statistically analyze what capacity our system has. It's a great tool to use to begin to start replacing your infrastructure too. So you get, and it's really nice when your calculations and what's being seen on the ground kind of correlate. When the two jive and everything makes sense, it really gives good justification for when you need to go in or replace it. So it works well. If we weren't able to do the modeling in-house, I don't know if it ever would have been able to been accomplished, because the amount of time and effort that we spent on it was large, and for a private consultant to come in and do that, it would have been very expensive. When you look at the dollar figures that a private consultant would have cost to do this, the city probably would have opted to use that money in a different way.
The applications are really kind of really restricted more by our own resources and what we can think of, I think, rather than by the capabilities of the system itself.
Because as our needs evolve, and sometimes we don't even know what questions to ask, using GIS for mapping and for analysis to give us the data that we need to do our planning